So we've defined what it means to be a critical number, where the value at that point of the derivative is 0 or does not exist. And with that, we know that a relative minimum or maximum will exist at that point. Then it is considered to be a critical number. Okay. So now how do we find an extrema or extreme values on a closed interval? So because it is a closed interval, we are considering these extrema to be absolute values or absolute extreme values. So from the theorem, if the function has a relative minimum or relative maximum at that point, then it is a critical number. So what it's saying is relative maximum or minimum only appear at the critical numbers. So we start by finding the critical numbers and then evaluating the function at those critical numbers within the interval a and b to consider all the possible values within the interval and then plug in values at the endpoint. Now, once we have all those values, we can compare all the y values or the function values, and the least of them will be the minimum and the greatest is the maximum. Okay, take note that finding the critical numbers is only part of the process, and evaluating the function at those critical numbers and the endpoints is the second part. Okay, for example, you're given the function 3x to the 4th minus 4x cubed on a closed interval -1, 2. We start by finding the derivative. So f prime of x is 12x cubed minus 12x squared. So to find the critical numbers within the interval -1, 2, so we don't know what numbers are those. Could it be -1, -0.5, 0, 1, 1.5? Within -1, 2, what we need to do is find the x values for which the derivative is equal to 0 or does not exist. So we set this equal to 0 and solve for x by factoring out the 12x squared. You'll get the other factor to be x minus 1 and set each factor equal to 0. And all x values for which the derivative does not exist. Now the derivative exists for all real numbers because there are no denominators. So if there was a denominator, we're going to set that denominator equal to 0 as well to find the rest of the critical numbers. So in this case, we only have the critical numbers 0 and 1. Now because, as I've said, because the derivative is defined for all x, it means the domain, what that means is the domain is -infinity to infinity. We can say that the only critical numbers are 0 and 1. So this is the first part. The second part of the process is plugging in those critical numbers. So we plug in the critical numbers 0 into the function and 1 into the function and find the values. F of 0 is 0, f of 1 is -1. Now, take note to plug it in or evaluate it to the function, evaluate these numbers, the critical numbers, into the original function and not the derivative. Because if you plug it into the derivative, you're just going to get 0. So going back, take note the function is 3x to the 4th minus 4x cubed. So plugging that in to the function will give us 0. Plugging in 1 into the function will give us -1. And then we will also evaluate the function at the given endpoints. And the given interval was -1, 2. So we're going to find f of -1 and f of 2. So now that we have all the function values, we just need to compare what's the highest and the lowest value. So the lowest value is -1, so this is our absolute minimum, and the highest value is 16. So that is considered to be our absolute maximum.